welcome to this tutorial. In this tutorial, we'll be learning about sequences and series. My name is Ademola Folarin, and this video is brought to you by iGota Virtual Learning. So by the end of this session, you should be able to differentiate between a sequence and a series. You should be able to differentiate between a geometric progression and arithmetic progression. And as well, you should be able to solve problems involving arithmetic progression and geometric progression. So let's start. What is a sequence? A sequence is a list of numbers arranged in a particular pattern. A list of numbers arranged in a particular pattern. So let's say we have numbers such as 2, 5, 8, 11, and so on. Or we have a number such as 7, 5, 3, 1, -1, and so on. This is what we call a sequence. Let's look at it. The very first one, we have 2, followed by 5, followed by 8. If we notice this, we will realize that this list of number is increasing by adding 3 to each term. So here, plus 3 is what we observe that is being added to each term. And let's look at the second one. 7 goes down to 5, goes down to 3. By virtue of this, we can see that we are being each number is gotten by subtracting 2 from the number before it. So that is -2. Because it follows a definite pattern, we call it sequence, the list of number that follows a particular arrangement. Then what do we call a series? A series is the addition of the terms of a sequence. By terms, we mean each of the number in a sequence is what we call the term. The very first number in a sequence is called first term. First term. So the terms in a sequence can be denoted using T1 for the first term, T2 for the second term, T3 for the third term, and so on and so forth till we have Tn. This Tn is telling us that any terms that we don't know where it may end. So the n can take the position of 5, 6, 7, 100, and so on. Let's liken a sequence to staircase in our various homes or schools. Each stairs is built by adding a common size to the one before it. So if this is the stairs, we can observe that if this one is a 2, adding a common value, the height to this, let's say we have 5. And if you add the number you have added to 2 to give us 5, if you add it to 5 again, you get another value, 8. The number you added to 5 to give you 8, if you add it to 8, you get another value, 11. So you can now determine the next because of the pattern this number follows. That is what we call a sequence. Why a series? It involves the addition of all the terms, such as we have 2 plus 5 plus 8 plus 11 plus and so on. Now to determine the n term of a sequence, let's say the Tn, we want to get the n term of this sequence. The sequence we have here, let's try to get the n term. We realize that the first term is 2, right? The first term is 2. So the second term is derived by adding 3 to the first term, that's 2 plus 3. So the third term is derived by adding 2 plus 3, add another 3, and so on. If we realize this, we can then say this is gotten by saying, okay, 2 plus, when the term is 2, that is the second term, we add just 1 3. When the third term, we add just 2 3. If it is the fourth term, we add 3 copies of 3. So we can realize that we are subtracting 1 from each, which means the nth term is gotten by saying the first term plus 1 minus the nth term, which is n minus 1. Then what are we adding? We are adding 3. Multiply by 3. So when we open this bracket, we get 2 plus 3n minus 3. And at the end, we realize that the nth term for this sequence is equals to 2 minus 3, which is minus 1. So we can move it that is equals to 3n minus 1. So if I follow this sequence now, if I need to get the fifth term of it, I will just say 3 multiplied by 5, that's 15, minus 1, I will get 14. So I believe if you continue with the sequence, that is what the fifth term will be. Interesting. Now that we know all this, we can now consider what we call arithmetic progression. Arithmetic progression. Okay. What do we call arithmetic progression? It is a sequence in which the difference between every terms are constant. It is a sequence in which the difference between every term are constant. So we know what a sequence is, we know the terms. So if we have this as a sequence, 3, 5, 7, 9, and so on. Or we have a sequence such as 8, 5, 2, minus 1, and so on. This is an arithmetic progression. We realize that the first sequence is increasing by addition of 2. Addition of 2. While the next sequence is decreasing by subtracting 3. So the value at which this sequence decrease or increase is what we call the common difference. So we call this one the common difference, and is denoted by D, is denoted with D, the common difference. Denoted with D, that's a common difference because that is what is common to them. Take for example something of this nature. This pattern of this is a sequence. The first term is 2. You had a particular value, you can see they added 3 balls, 3 rings to this to give us the next, and 3 is added to this to give us the next. So that is what we call an arithmetic progression. For every arithmetic progression, we have a common difference which is common to all of them. So in an arithmetic progression, the first term is always denoted with A, small letter A, that's the first term. While the second term is gotten by saying A plus D, and the third term will be A plus D plus D, where D is the common difference. So if it continues this way, this is the third term, we have 2D. So assuming we are going to the 10th term, we probably have A plus D in 9 places, because we are going to remove 1D from 10 to give us 9. So A plus D in 9 places, that's 9D. Hence, the nth term of an arithmetic progression, the nth term, which we can call T subscript n, can be derived by saying the first term plus 1 minus the term as n minus 1 multiplied by the difference. So this is the formula for the nth term of an AP. That's the nth term of an AP. That's the formula for the nth term of an AP. However, we can also say, if we are interested in finding the sum of any AP, let's say the sum of nth term of an AP. The sum of nth term of an AP is derived by saying, we begin to add this. Let's say, for example, we have the sum of these 3 terms, it will involve us adding all these together. So this is the number of terms. We get that by saying n divided by 2, open bracket, the first term plus this formula of nth term, which is A plus n minus 1, close bracket, multiplied by D, close it with bigger bracket. Which, if I want to summarize this, we can summarize this by saying the nth term, the sum of any nth term, let's call that the sum of any nth term of an AP, is saying the number of terms divided by 2, open bracket, this A plus A, let's call it 2A plus the number of terms minus 1, then multiply by the common difference. We know this now. We know what we call. So let's try to take an example from this. We have this example. Given an arithmetic progression, and we are being asked to determine the 8th term, the nth term, and the sum of the first 5 terms of an arithmetic progression. So to do this, let's first understand those parameters given to us. The first term that we always call A is equals to 5. So we will need to determine the common difference. Here, the common difference is gotten by subtracting the first term from the second term, or by subtracting the second term from the third term. So here we can say 11 minus 5. What would this give us? Whatever it gives us must also be the same as what 17 minus 11 will give us. So if we look clearly at that, that's 6. So we can say the common difference is 6. Now that we know this, then the very first problem say the 8th term For 8th term, our n is equals to 8 because that's what we are looking for. So the 8th term, we now say the general formula of the nth term of an AP is A plus, open bracket, n minus 1, close bracket, multiplied by the common difference. So here we have the 8th term, T subscript 8, equals A, which is the first term, 5 plus n, that's our 8 minus 1, multiplied by 6. And this gives us 5 plus 7 being multiplied by 6. Then I believe you can try this on your own. What will this give you? You say 7 multiplied by 6. Remember that's 42. Fantastic. 42. So when we add this together, that will be 47. And I bet it with you, if you continue this term to the 8th term, your answer should give you 47. That is the 8th term of this sequence. Now the next is to find the nth term. That is the general term that we can always use to get whatever value we are looking for in this. The nth term, as the B part, nth term. The nth term is the general formula that we can always use to get any term in a sequence. So the nth term equals, we already know the first term, which is 5 plus, since we don't know what n term could be, n remains n, minus 1, close the bracket, you multiply by the common difference, which is 6. So if we solve this, we have 5 plus 6n minus 6. That will be 6n minus 1. Therefore, the nth term of this given sequence 5, 11, 17, 23, and so on is 6n minus 1. Let's try to use it to get the 5th term. That means when we are talking about 5th term, that will be 6 times 5. That will be 30 minus 1, and that gives us 29. So let's add 6 to 23. What do we really get? 29. Oh, that's fantastic. Then we move to the last part, which is asking us to get the sum of the first 5 terms. Oh, sum of the first 5 terms. At this point, we already know the terms up to the 4th one. And interestingly, we can use the nth term formula to get the 5th one. Then we can add it together. Isn't that easy? Oh, yes, you said it's easy. What if in a situation where we are looking for the sum of the first 30th term? Are we going to be solving problem for each term? No. So then we introduce the formula. We are looking for the sum of the first 5 times. That's our S subscript 5. Sum of the first 5 times. We don't know that. So to know that, we use the formula of the sum of terms in an AP, which is the number of terms over 2, open bracket, the first term plus nth term, which is A, open bracket, n minus 1, multiply by d, close the bracket. So this, then we get sum of the 5 times, that's 5, equals, in this situation, because we are looking for the 5 times, the sum of the first 5 times, n will be equals to 5. Then that will be 5 divided by 2, open bracket. We already know the first term to be 5. 5 plus 5, oh sorry, this is plus as well, plus n, which is 5 times, minus 1, close the bracket. Our difference is 6. So this is 5 divided by 2. This gives us 10 plus 4 to be multiplied by 6. And if we solve all this together, we can say this is 5 divided by 2. The problem of this, 10 plus 4 times 6, that's 24, plus 10, that's 34. So what can we get from here? That can give us 5 multiplied by 34, which is 170, divided by 2. So whatever we get is our answer, which is 85. So the sum of the first 5 times here is equals to 85. And we have successfully solved problem involving AP. Now let's quickly consider discussion on geometric progression. Geometric progression. We know this now. So what do we call geometric progression? It is the sequence in which each successive term is obtained by multiplying a constant to its preceding term. Each successive term is obtained by multiplying a constant to its preceding term. What do we mean? Let's say this, the first time, let's call that one, let's pick any number, let's say 3. Now, if I multiply 3 by a constant, let's say I multiply 3 by 2. 3 multiplied by 2, that should give us 6. So 6 being the next term. If I multiply this by 2 again, that will give us 12. 12 being the next term. If I multiply this by 2, that will give us 24. So a sequence in this manner, 3, 6, 12, 24, and so on, is what we call geometric progression. This is geometric progression. Is increasing by multiplying a constant, which is 2. We can also have another geometric progression in form of this. Let's say 1 over 2, 1 over 4, 1 over 8, 1 over 16. We realize that in this first example, we are multiplying each term by 2. But in this second example, we are multiplying each term by 1 over 2. That is a geometric progression. A geometric progression. The sequence in which each successive term is obtained by multiplying a constant to its preceding terms. That constant that we multiply is what we call common ratio. Common ratio. Remember, we obtain something like this for an arithmetic progression that we call common difference. But for this, it's called common ratio and is denoted by R. Common ratio, R. So for a geometric progression, the first term is denoted by A. Then the second term, we multiply the first term by the ratio. The third term, we multiply the second term by the ratio, that's R. So instead of this, this becomes AR squared. The third term is also, the fourth term will become AR raised to power 3. And so on. So the nth term of A GP is denoted with A multiplied by R raised to the power of n minus 1. Remember, this is fourth term. The power here will be 3. This is third term. The power here is 2. So for any nth term, we subtract 1 from that position to give us the nth term of a GP. So the common ratio of a GP, which is R, how do we get that? We can get the common ratio of a GP by dividing the second term with the first term. You see, this is the second term. When we divide it by the first term, we get the common ratio, which is similar to dividing the third term by the second term. So that is how we get the common ratio of a GP. Now let's try to take example from this. Example. The question says, given a geometric progression, we should determine the common ratio. The ninth term and the nth term of this sequence. We should determine the common ratio, the ninth term, and the nth term of this sequence. So if we look carefully at the sequence, it follows 2, 6, 12, 24, 48. Let's not forget the first term, A is 3. So if we are looking for the common ratio, which is denoted with R, then common ratio will be equals to the second term, which is 6, divided by the first term, which is 3. And let's not forget, it must also give us the same thing as the third term, which is divided by the second term. And looking through this, we can say the common ratio is 2. That means each term is multiplied by 2 to get the successive term. Interesting. So the second question is that we should get the ninth term. For the ninth term, our n equals 9. So to solve this problem, we look the formula. The nth term of a GP, is always with the formula A R raised to the power of n minus 1, as we've learned a few minutes ago. Then we substitute the value. We know the value 3 multiplied by the common ratio, which is 2, raised to the power of n, which is our 9 minus 1. So when we solve this problem, we have 3 multiplied by 2 raised to the power of 8. So if we can get that on our own, then the ninth term, which is u of 9, that's what we have done here, u of 9, is equals to, when you have 2 raised to the power of 8, what would that give us? Okay, 256, right? That will be 3 multiplied by 256. You can as well confirm that. 256 multiplied by 3, then we have 768, which is the ninth term of this given arithmetic. And lastly, we are to find the nth term. Which is the general formula that can be used to solve for any term at all. The nth term. Remember, the n term of a GP is equals to the first term multiplied by the common ratio raised to the power of n minus 1. So for the n term, we don't know what n is. It can be any value, but we know the first term to be 3 multiplied by the common ratio for this sequence, which is 2 raised to the power of n minus 1. Hence, we can conclude that for this sequence that we are working with, if anyone is continue writing this sequence, the person should just use this formula: 3 open bracket 2 raised to the power of n minus 1. That is the nth term of this sequence. Interesting. So we've learned about sequence and series in this video. Sequence involves the list of number in an organized pattern, in a particular pattern, either by increasing, by adding a number, or by subtracting a number, or by dividing it, or by multiplying a number. But it has to follow a particular pattern, and it must be a common value. For series, it's not by multiplication. When the terms of a sequence is being added together, such as maybe 3 plus 6 plus 12 plus 24 plus 48, such is called series. For an arithmetic progression, the successive term increases or decreases by a common difference. However, in geometric progression, the successive terms is obtained by multiplying the previous term with a common ratio. So we observe that arithmetic progression involves addition and subtraction. You add a common value or you subtract a common value. For geometric progression, it involves multiplication or division. You multiply each term by a common ratio, or you divide each term by a common ratio to get the successive term. So if you enjoyed this video, don't forget to subscribe to this channel, and as well click on the like button for more interesting educational video like this. Thank you.